Okay. It's almost 8 o'clock. So I will start the meeting. Okay. Okay, so I have already started this chapter. I have taken 2 classes already on this chapter, and those 2 classes I posted on my YouTube channel, and I requested all the students to watch them. So I hope that you guys watched them. And so I can now continue from where we discontinued. Okay, so this is page 21. So just a real quick recap. What is the difference between elements and compounds? I remember I did the atomic structure with you guys. I talked about the concept of molecules and the elements and compounds and all of that. So just a quick recap. What is the difference between elements and compounds? Yes, Hassan. Yes, Hassan.
Yes, ma'am. Elements are made of one type of atom, while compounds are made up of multiple types of atoms.
Yes, good job. Yes, perfect. Elements meaning that only one type of atom is making that substance. So when a substance is composed of only one type of atom, we call it an element, simple. And when a substance is made up of more than one types of elements, then we call it compound, okay, simple. Element is a substance that is composed of only a single type of atom, and compounds is a substance that is made up of more than one type of atoms. So, which of the following are elements and compounds in this table that I'm showing? Which one is an element and which one is a compound? Yes, Sidra?
The first one is an element.
No, don't say first one, say the name.
Nitrogen is an element.
Very good.
And ammonia is a compound.
Why is it a compound? Because
there's another
because we can see that there is nitrogen atom at the center and 3 hydrogen atoms attached to it. So there are 2 types of atoms, nitrogen and hydrogen. So therefore that makes this molecule a compound, right? Okay, now let me ask others. What about HCl? Okay, Abdullah. Yes, Abdullah. What about HCl? Is it an element or a compound?
It is a compound.
Why?
Because there are 2 molecules in it.
2 molecules? 2
Yes.
types of atoms. 2 types of atoms. What's the difference between atom and molecules?
Atoms are smaller than molecules.
Is that it?
And a molecule is made up of atoms.
Right. A molecule is made up of more than one atom, right? An atom is just single. It's just single particle, whereas molecule is also a single particle, but it is made up of 1 or more atoms. It is made up of more than one atoms, right? So if you have a single atom, then that's an atom. But if you have more than one atom is bonded together and behaving as a single particle, that is called a molecule. So when you will, so you cannot say that there are 2 different types of molecules here, okay? You will say 2 different types of atoms together have made one molecule. And this molecule, it will be called a compound, right? Okay, what about this, chlorine? Okay, I will ask Zorez. Yes, Zorez?
Hello? Chlorine is an element.
Okay, why? Because
there's only one type of atom, chlorine.
Right. Very good. Yes. So we are talking about the type of element. I mean, the type of atom. We are not talking about the number of atoms. So there are 2 atoms, but because both of them are the same type, meaning both of them are chlorine, so therefore this is an element. Okay. So I'm not saying Don't confuse this. I'm not saying that 2 atoms will make a compound. No, more than one type of atoms will make a compound, right? Okay, now, what is a formula? You know, these are formulae. This is how, like, we cannot write the whole name of the chemical all the time because then it would be
Like the
tedious,
chemical.
time consuming. So yeah, we use symbols, we use formulae. So what is a formula in chemistry? Can anybody define formula? Yes. Yes, Afan? Is that you or is that Ariha? Ariha? Yes, Ariha? Okay, Momina. Yes, Momina? Yes, Momina? Hello? Okay. Afifa. Yes.
Yes, teacher. Formula. The formula tells you which amount
Yeah,
of
what is a formula? My question is, what is a formula? How would you define a formula?
um,
Okay. Okay, I don't have time, so I will just get to the answer. Okay. So a formula represents the number of each type of atom in a formula unit. A formula denotes the number of each type of atom in a formula unit. What is a formula unit? Formula unit, don't be confused. This, you can even use the word molecule for now. So it represents, a formula tells us the number of each type of atom in a molecule. Simple. Let's keep it simple for you guys. A formula shows the number of each type of atom in a molecule. For example, this is a molecule. So now the formula is telling us that there is 1 atom of carbon and 4 atoms of hydrogen. Okay, so the formula is telling us that in this one molecule, there is 1 single carbon atom and 4 hydrogen atoms. This formula is telling us that in one molecule, there is 1 atom of phosphorus and 5 atoms of chlorine. This is another formula. This formula is showing us that there is 1 atom of nitrogen and 3 atoms of hydrogen. And this is showing that there is only 1 atom of sodium and 1 atom of chlorine. So I hope you get the idea. So formula is where we use symbols for the elements. In my last class that I took regarding atomic structure, and I talked about the periodic table. Periodic table is given at the back of your book, and you can see in that periodic table that each element is given its name, symbol, and an identification number, which we call atomic number. Now you can see in each box there are 2 numbers given. One is bigger than the other. One is smaller and the other is bigger. So remember, the bigger number is the mass number, and the smaller number is the atomic number, which is the number of protons, right? The name is written as well as the symbol. The name is written as well as the symbol, right? So we use, in formula writing, we use the symbol. In formula writing, we use this symbol. And by constant practice, you will learn the symbols for different elements, okay? So don't worry. By constant practice, you will learn the symbols of the elements. Okay, now let's move on to what is a chemical reaction? What do you understand by a chemical reaction? Don't do this. Use this, use this like this. What is a chemical reaction? I know there are, yes?
chemical reaction is when the molecule or compound totally changes into another.
Yes, okay, good. Sidra said that when a molecule changes into a completely different one. Yes, that's absolutely right. A chemical reaction. Okay, Anas. Let's see what Anas has to say. Yes, Anas? Yes, Anas?
Chemical reaction.
Yes. What is a chemical reaction? Whatever you understand, tell me.
It is a change that cannot be convert back, and that takes heat or energy, and or take it or given out, and the material we got, it can not be changed back to its original form.
Okay. Okay. So basically, a chemical reaction is when one substance changes into another substance. One or more substance get converted to one or more different substances. Okay. Chemical reaction is when one or more substance gets converted to one or more different substance. For example, what do I mean by that? For example, I will take this example. I took iron and then I took sulfur. Now this example is given in your book. So I took this example from your book. So you have iron and then you have sulfur. Okay. Now both of them combined to form this compound. Why compound? Because it has two types of elements. Okay, what are the two types of elements? One element is iron, the other is sulfur, right? So this is a compound. What is this? Is this a compound? Is iron a compound? Is sulfur a compound? No. Why? Because iron has only one type of atom, which is iron. We can see iron in the periodic table. Take the periodic table out. So iron is one type of atom. Sulfur is one type of atom. So they are elements, right? Iron is a transition metal. It's in the periodic table, it's a transition metal. No, show them this box. Now also get yourself familiarized with this periodic table. Okay, on the left hand side, we have metals. On the right hand side, above this staircase, we have non-metals, and these are transition metals. These are also metals, but they're slightly different from these other metals. Okay, so I got iron from here. This is iron. Okay, this is sulfur here. Okay, so these are elements because they are made up of only one type of atom. Now iron sulfide on the other hand is when, so let me make it this way. So this is an element. Okay, I'll write element here. This is also element. Okay, for example, this is iron. Okay, this is iron atom, for example, and this is sulfur. Okay, they combine together to form this iron sulfide. This is sulfur, this is iron. So can you see this one atom here, they combine together to form iron sulfide. Now this is one molecule, but it is made up of two different types of atoms, iron and sulfur. So that makes this a compound. Yeah, okay, I'll explain you that as well. Okay, now the substances which are reacting together, are called reactants. They are called reactants. And what you get at the end is called a product. What you get at the end of a reaction is called a product, and the substances that react with each other are called the reactants. Right? Now, I want to discuss this experiment with you. Okay, another question that says, Sidra just asked me, why are we calling this ide? Why did the name change from sulfur to sulfide? Iron name did not change, but the sulfur's name changed. Why did that happen? The answer to that is that whenever you come across a name, a chemical name, which ends in ide suffix. What is a suffix? Remember you did suffix in English spellings?
Which comes at the end.
Right, a group of letters that comes at the end. So we use a suffix ide when only two different types of atoms make a compound. Okay, like sodium chloride. We will do more examples, and then this iron sulfide. So the reason why we have ide at the end is because it is made up of only two different types of elements, or two different types of atoms. The exception is only hydroxides. Hydroxides are the only exceptions. Okay. Now, for those students who have just recently entered into grade 6, this must be a lot of bombardment of information. So I do understand this, but keep reading and keep listening. Don't get confused. Just try to absorb as much as you can. Okay, you have my recordings. You can access them anytime you want. So read the book at your own convenient speed, and then refer to my videos. If still you don't understand anything, you're most welcome to ask. Okay. And by the way, I like educational questions rather than questions like, you know, what is the schedule and what is this, and can we have copies of this book and that book? These sort of questions, like I won't be able to address these questions. But if you ask me an educational question, I will be more than happy to answer. Now, sometimes, okay, I'll do the rest of it later. But first of all, let's discuss this experiment 2.3. Okay, before we start this experiment 2.3, another thing that I want to talk about is that the product that you get at the end of a reaction is totally different from the reactants, meaning that it has completely different physical and chemical properties from the reactants. Meaning iron sulfide will be physically and chemically absolutely different from iron as well as sulfur. They have completely different, like they have no relationship at all in their physical and chemical properties. So chemical reaction is a process in which one or more substance get converted to an entirely different substance which has entirely different physical and chemical properties from the reactants. Okay, that's a proper definition of a chemical reaction. But don't worry, you don't have to ratify right now. Right now, just try to understand. Just try to absorb as much as you can conveniently, absorb. Okay, now this experiment is what I want to discuss. 2.3 on page 23, or maybe the page number is different in your new book, but this is the experiment. Okay, those of you who have the book can open and consult. But so I want to show you how iron looks like, and I'll share my screen. Okay, I'll show you. I'm sharing my screen. Okay. How does iron look like? This is iron. Okay, this is how iron looks like. Yeah. These can also be called as iron filings. So can anybody describe them to me? So Sidra, you want to try describing this iron? So what, first of all, you'll talk about? You'll talk about the color, you'll talk about the texture, you'll talk about, yes, appearance, yes?
So it's like in silver, darkish black color.
Gray
color, and
yes.
It feels like very like powder.
Right, it's in a powder form. The particles are small,
And,
fine.
It is attracted by a magnet.
No. Whatever you can see. You have to describe whatever you can see. So yeah, so you have described it. It's gray in color. It's silvery. It has silvery, shiny appearance, and it is powdery. Okay. Now, this is sulfur. Okay. Now, now who wants to describe sulfur? Now look at the picture first and then describe it. This is how sulfur looks like. Yes. Who will describe sulfur? Okay, Shaima. Yes, Shaima? Shaima, I have unmuted you. Okay, Jameel Khan? Yes?
Yes.
Can you describe sulfur for me? Yes?
Yes. Will you show the picture of it?
Okay, I'll show you again. This.
Yeah, it's like a yellow powder.
Very good. Yes, it is yellowish and it is powdery. Okay, good job. Yes, okay. Because, you know, in exams, they sometimes ask you to describe your observations, and that carries 1 mark, 2 marks.
Okay.
So you should be able to tell your observation. Okay.
Yes, teacher.
Yeah, okay. So mute yourself now. So this is iron, this is sulfur. Now you know how they look like individually, right? This is iron, this is sulfur. Now, how does their mixture look like? If I mix them together, if I mix that grayish silvery powder in this yellow powder, this is how the mixture looks like. I simply mixed, right? So this is how the mixture looks. But if I now heat it in a test tube, if I now heat this mixture in a test tube, how will that look like? And at the end, what will that look like? That will look like this. This is iron sulfide.
Why is it like
Yes, so this is iron sulfide, absolutely different from both iron as well as sulfur. Like you cannot even tell if this came from those two substances, right? This is a chemical reaction. When the product is completely different from the reactants, product is what you get at the end of the reaction. Reactants are substances that are reacting to give us the product, right? Right. Now I have a small video. I'll show you that video in which the video will show you how when sulfur and iron are mixed together simply in the form of a mixture, nothing happens. And also you can easily separate iron from silver. Can anybody suggest a method of separating? You have done separation of mixtures, right, in grade 5? You have done separation of mixtures in grade 5, remember? So now tell me, how can we separate iron from sulfur? Yes, Sidra?
we can take a magnet and attract all the iron fillings, then we'll be left with iron sulfide and then remove the iron
Okay, is
fillings.
there any other way? Any other way? Your book says give
filter.
2 ways. Give 2
Filter.
ways.
Filter.
Filter.
Because like sulfide is like more like, sulfur is more like powder than iron. So it might pass through.
So you mean to say that sulfur particles are finer than iron filings?
Because iron is like metal.
And so, yeah, you can make use of the difference in the sizes of their particles, provided this difference in size is significant. Okay, otherwise both of them can pass through your sieve, whatever sieve you're using.
But I
So
feel like iron
yeah,
is
or another way could be if we can have a solvent that can dissolve only one of them,
and
not both of them but one of them. If we can have a solvent that can dissolve only one of them, and then we can extract the one that did not dissolve, right? That's another
and then
way.
evaporate that solution and get that.
Yeah, so yeah, but is there any other such suggestion from any other participant on how to separate iron from sulfur? Okay, Rayan Musharraf, any ideas? Any suggestions? Abdul Rahman. Okay, if you don't want to answer, then please lower your hand. Abdul Rahman Amir, please lower your hand if you don't want to answer. Who is this Vivo? Vivo, I have unmuted you. Yes. Yeah, what's your name?
Umar,
Yeah, please use your real name. Okay, now tell me the answer. Do you have any suggestion on how to separate sulfur from iron filings? No? Okay.
no,
Okay, let's move on. So, okay, wait. Now I'll show you a video in which there's an experiment going on. They are mixing sulfur with iron, and then there's a simple mixture first of all, but then that mixture will be heated in a test tube, and you will see how that will turn into iron sulfide. Okay, so I am Okay, now I'm showing you this video. This yellow powder is sulfur and this grayish blackish powder is iron. Now the sulfur powder will be mixed with iron filings. Yeah, using a spatula. This is a spatula that she's using. And these fishes are called. Yeah, now she is separating iron with the help of this magnet. Now, because iron is magnetic, it can be easily separated with the help of a magnet. So see how she has separated the iron filings with the help of the magnet. Now, all the iron filings have been separated. Now, this mixture is being heated with using a flame. Okay, now be careful while heating because this can give dangerous fumes. So this experiment should be done in a fume cupboard. And I will talk. Yeah, with continuous heating, you can see iron sulfide being formed at the bottom of the test tube. This grayish thing that you can see at the bottom of the test tube is iron sulfide being made. Right. So iron sulfide is being made. Okay. Now they have cracked open the test tube and taken this iron sulfide out. Now this is iron sulfide. Now this is completely different from sulfur. Now can you see the magnet cannot attract the iron? Now she has brought the magnet closer, but the magnet did not attract any iron. Why? Why didn't the magnet? Why couldn't the magnet attract the iron in the iron sulfide?
Turned into some totally other compound, so now it cannot attract.
Okay, Hiba Iftikhar, you want to answer this? That why couldn't the magnet attract iron from iron sulfide? Okay, Zores, you want to answer?
Yes, ma'am.
Okay.
Yes. But because of the reaction, the magnetic ability of the iron is gone.
Very good.
Because
Yes.
they form of matter and it's not pure iron.
Very good. Good job. Yes. So that means you've understood. Yes. Iron has lost its magnetic properties. It's no longer simple iron. It does not have the same physical and chemical properties. Now it is chemically bonded to sulfur. Okay, it is no longer magnetic. Only pure iron, only simple elemental pure iron is magnetic. Okay, good job, Zores. Now, in your book, in this experiment, they have used a symbol. What does this symbol mean?
Caution.
Yeah, this means caution, meaning you got to be careful while carrying this experiment out. Why should you be careful? Fume cupboard. What is a fume cupboard?
To make sure.
Who knows what a fume cupboard is? Urwa bin Masood? Yes, Urwa? What is a fume cupboard? Okay, Atika, you tell me. Yes? Atika?
A fume cupboard is a cupboard in which all the gases produced from the experiment that we're doing are taken in.
Okay. All the
Yes, absorbed by the cupboard.
Yes, and why do we use it? Why do we use it? And
we use it to prevent toxic gases being inhaled by us.
Very good. Yes, it is for our safety. This is for our safety so that the dangerous and the toxic fumes that are produced in this experiment might not be inhaled. And you can see that there is loose plug of mineral wool also inserted at the mouth of the test tube. Can you see? Loose plug of mineral wool. Again, the purpose is same, to prevent the fumes from arising. Also, we don't want these fumes to react with the flame, because the sulfur might react with the oxygen in the air and form sulfur dioxide, which is a toxic gas for us. Yes, you want to say something? Right, and it also prevents a sprinkling of the reactants. Sometimes the reactants, before they could react, start sprinkling out, because as you can see, the test tube is very small and we are using direct flame. So yeah, we have to be careful. Okay, so that is why it is stop heating once the reaction starts. Stop heating immediately once the reaction starts, because we don't want these dangerous fumes. We don't want these dangerous fumes to be inhaled, first of all, by us, and we don't want any explosions or any splurting of the substances out. Right. Then give your test tube to your teacher when it has cooled down. Your teacher can wrap the tube in a cloth and crack it carefully to get your new compound out. Just like in the video that I just showed you, the bottom of the test tube was broken, and then iron sulfide was taken out. So what are the differences between the mixture of iron and sulfur and the new compound you have made? There's a big difference.
That it's like a rock.
Yeah, now it is in solid state. First they were in powdery.
Yeah.
Both of them were powder, and now the final product is
And
solid.
it's in a different color.
Yes, and the color is different.
And
The color is different, and it's hard. Right, and also chemically might be different. Right, okay. Now let's move on then to the next point, which is, okay, now let's discuss the naming of compounds a little. Okay, now let's talk about the naming of compounds. Pull your chair forward. Okay. Yeah, hold this. So we talked about "-ide". When do we use "-ide"? We use the suffix "-ide" when only two types of different atoms make a compound. Exception is hydroxide. And when do we use suffix "-ate"? ATE. When do we use "-ate" at the end? When there is oxygen in the compound. And you will see that oxygen is usually written at the latter part of the formula, not at the beginning. Okay, we will talk about that later. In the next class, I will only talk about formula writing. The whole class would be based upon how to write formulae. Okay, I will only talk about formula alone. So copper sulfate, silver nitrate. So you can see the 8 at the end, right? The 8. That's because these compounds have oxygen in them. You can see the oxygen, right? Right. So I can write the equation this way. I can write this reaction that I just showed you this way. Iron plus sulfur giving me iron sulfide. This is called a word equation. This sort of an equation is called a word equation. And then we can also use symbol equation, where we use the symbols of the elements using the periodic table. So the symbol for iron is Fe. Symbol for sulfur is S. And when these two combine, we write iron sulfide. So this formula tells us that there is one atom of iron bonded with one atom of sulfur, right? Okay, now most of the chemical reactions, not all, but most of the chemical reactions are difficult to be reversed. Meaning now once you have iron sulfide made, you cannot get the iron and sulfur back. Like, you know how easily you could get the sulfur back from the mixture by just using a magnet, right? But now, once the reaction has completed and now you have iron sulfide, now can you get sulfur back from that iron sulfide, or can you get iron back from iron sulfide? No.
Because it doesn't have the same properties, so you can't use it.
Right, because now they are together one substance. Now they are together one substance, not two different. So it's not easy to get these reactants back. So this is one of the characteristic features of chemical reactions, that you cannot get the reactants back easily. But this is not 100% in 100% of the cases, but yes, mostly. Okay. Yes, that's what I'm saying, that this is not true in 100% of the cases, but yes, mostly it is true. Now another example is sodium plus chlorine giving us sodium chloride. This is another a daily life substance that we use in cooking, in our food. Sodium chloride is salt, simple table salt, right? Now table salt, as we can look at the formula, has one atom of sodium and one atom of chlorine. Right. So this sodium itself in the elemental form, in the pure form, is completely different from chlorine in the pure form. Let's talk about how they look when they are in their pure form. I'll share my screen again. Okay. Okay. So this is metallic sodium. This is how metallic sodium looks like. Silver, gray, shiny, but not in a powder form. This is in block form, right? But it's not that hard. You can cut it easily. You can cut it with a knife. It's not that hard. So we need to touch these substances. You know, it helps. Now this is chlorine gas. This is chlorine gas. Can you see the color? What color is this? Yellowish green or greenish yellow? Can I call it greenish yellow?
This is liquid or gas?
Yeah, this is gas. This is gas. So chlorine exists as a gas at room temperature. And sodium, because it's a metal, is a shiny solid at room temperature. And chlorine is a non-metal. Most of the non-metals exist as gases at room temperature. So this is chlorine.
Is this one?
So you can see that this is a greenish yellow gas, right? Now these two together, you can see their appearance. Now these two together give us this salt that we eat in our food. So how different are they? Can you even imagine that this table salt is made up of these two elements? No way. What? Right. Now chlorine is deadly. It's poisonous. Okay, we cannot inhale chlorine gas. That's why if any experiment releases chlorine, we have to use fume cupboard. Even the sodium is toxic. Okay, and explosive. You have to keep sodium away from water. Okay, there you can have explosions if this comes into contact with water. So yeah, so these two are toxic, and together they make such a harmless substance, table salt, that we eat every day in our food. So how amazing is that? Huh? Okay, so now I am sharing my video, okay. So it's, now I can have a similar word equation for this reaction, sodium plus chlorine, giving us sodium chloride, and I can use the symbols and give you a symbol equation as well, sodium plus chlorine giving us sodium chloride. But one thing that you have to keep in mind is that when we write a symbol equation this way, we keep in mind that we have to ensure that we write these substances in the state that they exist in. Okay. Now, what does this mean? This just means single atom, but chlorine does not exist as a single atom. Okay, it exists as a diatomic molecule. Remember this picture in here? Chlorine exists as a diatomic molecule. Page 21. So this is the normal form in which chlorine exists under normal conditions. Okay, now sodium, yeah, these are two atoms of chlorine. Yeah, so you won't have chlorine single atoms. You won't have single chlorine atoms. Okay, two atoms will always combine together to give you a simple molecule. Okay, now sodium also exists as a metal. Okay, so metals we can write as they are, because they form giant lattice, right? Cations embedded in the sea of electrons. So it's okay to write sodium this way. So this is the proper symbol equation for reaction between sodium and chlorine, because chlorine exists as a diatomic molecule. So I used 2. Now what is this small 2 doing here? This is small 2 is representing the number of atoms of chlorine within the molecule. That means 2 chlorine atoms together make 1 molecule of chlorine. Right. So these small numbers that you see on the right lower side of the symbol represent the number of atoms. This small number represents the number of atoms in a molecule. Okay, exactly, like, you know, oxygen. When I write oxygen, I put a small 2 here. What does this 2 represent? This represents that there are 2 oxygen atoms within an oxygen molecule. Right, now, but what about this 2? What about this 2? Why did I write 2 here on, you know, on the left side? Now, this will tell me the number of the whole molecule. This will tell me the number of the whole molecule. This was telling, this number, this small number was telling me the number of atoms per molecule. This was number of atoms per molecule. Like, for example, let me make this easy for you to understand. If I make a picture or a diagram, like this is 1 atom of sodium, right? Reacting with, give me a different color marker. For example, this is chlorine, okay? 2 atoms of chlorine together making 1 molecule, together reacting to give, sorry, should be right, red sodium and then chloride. Okay, this way. This. They are together, but yeah. They're close to each other, but they are not, yeah, like this. Okay, this is this way. So now, can you see that this is not balanced? We have 2 atoms of chlorine here, but only 1 here. We have 2 chlorine atoms here, but only 1 here. Where did the other chlorine atom go? Yeah, so we need to balance it. So we will make 2 sodium chlorides. I will make 2 sodium chlorides. So, okay, now we have 2 chlorine atoms here and 2 chlorine atoms on the left side, 2 chlorine atoms on the right side. But what about this sodium now? There are 2 sodiums here and only 1 sodium here. So where did this come from? So I will add 1 more sodium here. And yeah, now we are balanced. 2 sodium on the left side, 2 sodium on the right side, 2 chlorine atoms on the left side, 2 chlorine atoms on the right side. Now, how will I write in the symbol equation form? So I have 2 sodium atoms separate. I have 2 sodium atoms separate, right? So I will write 2 sodium, but this is 1 molecule. This is 1 molecule. So I will not write anything. When I don't write anything, it means 1. But a small 2 here because there are 2 atoms within the same molecule. There are 2 atoms within the same molecule. So remember, this small number that I write on the right lower corner depicts or represents or shows, tells us the number of atom within 1 molecule. Whereas this big number will tell me the number of molecules themselves. You can think of it that way, right? Wait. And then these are 2 of them, right? So 2 of sodium chloride, 2 of sodium chloride. Now Sidra is filled with questions for me. Okay. Yes, ask. Yeah, ask loudly so that they also hear your question. Yes.
Chloride has like 2 atoms. So why do you need to add another sodium atom? Like,
okay, this is not chloride. This is chlorine molecule. Chlorine molecule. You will not, because this is not a compound. Can you see that this is not a compound? This is an element. So you cannot have "ide" at the end. Okay, don't call it chloride. This is chlorine. Chlorine. Okay. Yes.
but you say they always come on their own.
Yeah.
Right.
No. They never exist as single atoms. They always exist hand in hand. You know, diatomic molecule. Chlorine is a diatomic molecule. Okay. Now, another thing is when you write a symbol equation, a chemical equation this way, it is also important to mention the state symbols. It is also important to mention the state symbols. Now, what do I mean by state symbols? Like, what state of matter do they exist in? Okay, how many states of matter do we have? Yes, we have more than 3, but yes, we'll deal with 3. Solid, liquid, and gas. So we have 4 states of matter: solid, liquid, and gas. And then we also have some substances which are dissolved in water, those which are soluble in water. For them, we use the term aqueous. Aqueous from aqua. Aqua, which is Latin for water. Okay, so solution. So these are the 4 states of symbol. So we want to know which one of these a substance exists in, as a solid, liquid, gas, or dissolved in water in the form of solution, in which case we will use the symbol AQ. So what are the short form symbols that we use? For solid, we use S. For liquid, we use L. For gas, we use a small g. Okay, and for aqueous, we use AQ. For aqueous, we use AQ. So putting in the state symbols here, sodium would be solid, chlorine would be, remember, it's a gas, I showed you, it's a gas at room temperature, at a standard room temperature. And a standard room temperature is 25 degrees Celsius, 25 degrees Celsius. And sodium chloride table salt is, yeah, it is aqueous, but in this particular case, it is not aqueous. Yeah, this is solid. Yeah, this is solid. Okay. Okay, now let's do a few questions regarding what we learned today. Let's do some questions. Is there any question? I'm sorry, I have disabled the chat option today. The chat option is disabled today. I'm sorry about that. So I will have to unmute you, and please only those people who really want to ask a question raise their hand. Otherwise, I wouldn't know and it will waste time. So are all of these hands raised because they want to ask questions? Anas? Yes? Yes, Anas?
I want to ask a question that what is this why is the sulfur I came late, that's why can you tell me why is it iron same but sulfide different? I was busy.
You'll have to listen to my recording.
I left for a second.
Yeah, you'll have to listen to
Okay.
my recording. Yeah. Okay, Abdul Rahman Rahim. Yes, you want to ask something? Yes.
Teacher, what is like the gas? Why is it so toxic?
Okay. Why is it so toxic? You know, like, yeah, because, you know, it reacts with our body the wrong way and it is poisonous for our body. Okay. Okay, now let's do the questions that I show, the end of chapter questions. Lower all hands. Am I raising? Am I? Okay, I want to share my screen. Okay, we'll do some questions. Okay, I'm doing end of chapter questions. Okay, this is the end of chapter question from the same book, Chemistry for You. Look at this candle burning. Which label, A or B, shows a chemical change and which shows a physical change? Explain your answer. Now, only the person who really wants to answer this question should raise hands, okay? Maz. Yes. Yes. Yes, Maz, you are unmuted.
Yeah, I have a question, but I'm not answering. I have a question. She's saying I have a question.
Yes. Okay.
The salt which is made from these all poisonous things. So why is it not harmful for, like, it's also made from the toxic gas? So why we eat, but it is not poisonous to us. It is not harmful to us. Why is it like this?
So that's what I was explaining you. That's what I said, that when the elements combine with each other, they totally lose their physical and chemical properties. So see how poisonous chlorine was before binding, but once it is in the form of a compound, it's no more poisonous. So it lost all its poisonous properties. Okay. Okay. Zainab Ehsan. Zainab Ehsan. Okay, Shaima, you answer.
Miss, I have a question.
Okay.
Miss, I didn't understand periodic table.
Yeah, I never explained the periodic table. We will do periodic table in detail in later chapters. Okay, that was just a reference. I was just showing you that iron is a pure element. It has one type of atom. So
Oh,
that's why.
okay, miss.
Yeah. Okay. Do you want to answer this question?
I can try, I think.
Okay. Look at this candle burning. Which label, A or B, shows a chemical change and which shows a physical change? Explain your answer.
B shows a chemical change and A shows a physical change.
Okay. Explain now.
As in B is melting and we cannot change it back to solid again.
B is melting. Okay. And so
Candle
that.
is melting.
Yeah, so B is melting. Okay, you're correct. So is melting physical or chemical change?
Physical.
Physical. Okay, so it's a physical change, right? B is physical, and because it's melting, and what makes a change physical?
I was thinking it's because melting and it cannot change back to solid, so I thought it was a chemical change.
No, it cannot change back to solid. Why not?
It can
No.
change back to solid? I don't know that.
Listen, when the wax melts, and if it is left unheated at room temperature, what happens to it? It solidifies again, right? It's
Yes.
all, yeah. So B is a physical change. Okay, Sidra. Okay, Jazakallahu khairan, Shaima. Okay, Sidra. Okay, who wants to answer? Rumesa Niazi. Yes. Okay, Rumesa Niazi.
Yeah, miss. The B is a physical change since when it melts, it changes back to solid, while A is a chemical change because
Why?
because
Yes.
it's burning, and burning is a chemical change.
Right, and because the wick, which is made up of a piece of cloth, is burning, meaning it's reacting with oxygen, and it is
Yes.
turning into ash, and you cannot have ash converted back into cloth. So most of the chemical reactions are irreversible, meaning we cannot get the reactants back. Whereas in B, the wax is still wax. Okay,
Yeah.
it hasn't turned into anything different, and it solidifies back again if you lower down the temperature, right? Okay, thank you. Okay, next question. Okay, is this, okay. Some rescue flares contain aluminum powder. It reacts with oxygen in the air to form aluminum oxide, a white solid. Is this a physical or a chemical change? Sidra is saying chemical. Why, Sidra?
Because it's changing into something outside the react, because it
Right.
reacts with oxygen in the air to form aluminum oxide, and there's "ide" at the end. That means it's a
Right. Okay.
object.
Okay. So who wants to answer this? Javeria. Yes, Javeria.
Okay.
Yes. So some rescue flares contain aluminum powder. It reacts with oxygen in the air to form aluminum oxide, a white solid. Is this a physical or a chemical change?
It's a chemical change because it makes a new substance,
Which is?
aluminum oxide.
Very good. And which is absolutely different from? Aluminium
Aluminum.
as well as oxygen. Right. Write a word equation for the change. Okay, okay, Sidra wants to write. Sidra wants to write. So let Sidra write. Okay, Sidra. I show you the question. Okay, aluminium, write down the symbol for aluminium. Do you know the symbol for aluminium? Okay. Okay, I'll tell you the symbol for aluminium. It's Al. Capital Al. Here. Okay, this is our periodic table. Keep the periodic table with you. Aluminium is here. This is the symbol aluminium. So write down aluminium and be fast. Yeah, aluminium is reacting with oxygen. Symbol is O. But does it exist as a single atom? Ask yourself. And does aluminium exist as a single atom? Yes, it does, because this is a metal. It does, but oxygen is a diatomic molecule. Okay. And then they're combining together to form aluminium oxide. And in the question, they have given you the formula Al2O3. Al2O3. Where's the question? Can you please take out the question? Yes. See, you have to write your Al2O3. Your numbers should be small on the right hand side. Numbers should be small on the right hand side. Right. Yeah, this is the formula. We will do formula writing in the next class. Okay, so don't worry about the formula and don't even worry about balancing. But yeah, this is symbol equation. You wrote down symbol equation. This is symbol equation. Write down word equation. I want you to write word equation. Now write down the spelling for aluminium, oxygen, and then write down aluminium oxide. Be fast, be fast. Only 4 minutes are left. Yeah, this should be written with capital A, aluminium, okay, plus oxygen, giving, right here, aluminium oxide. So same spelling, aluminium oxide. Right, okay. So we will do the balancing of equations later, okay? Okay, next question. The list below contains 3 elements and 3 compounds. Say which are elements and which are compound. Aluminium. No, let them. Aluminium. Yes. Muhammad Abdul Ahad. Yes. Yes, Muhammad Abdul Ahad. Is aluminium an element or a compound?
Aluminium is a metal, so it is an element.
Good job, good job. Because see, whatever you can find in the periodic table, is an element. Okay, remember this. Whatever you can find in the periodic table is an element. Okay, next, ammonia. Ammonia. I just asked. Okay, so let's move on. Carbon dioxide. Carbon dioxide. Okay, Taha Kashif. Carbon dioxide, is it an element or a compound?
Carbon dioxide is an
Carbon? Yes, very good. Yes, why? Carbon dioxide.
Carbon dioxide.
So carbon is one element, and then oxide, oxygen. So there are 2 elements, right? So that makes this a compound. Taha, did you understand? Right. Okay. Okay. What about sulfur? What about sulfur? We just did in iron sulfur. Sulfur is an element. Okay. Copper. Who will answer? Copper. Furqan Azhar. Yes, Furqan? Furqan? Okay. Momina?
Yes. Can you please repeat?
Copper. Is copper an element or a compound?
Element.
Very good. And what about water?
Compound.
Why? Because?
H2O.
So that means it has
So
how many types of elements?
2. Hydrogen and oxygen.
Good job. Good job. This was easy. Okay, let's move on. Choose words from the list to complete the sentences below. There are about dash naturally occurring elements. Now this is written in the chapter. There are 92 naturally occurring elements. From these elements, dash of different substances are made. Millions of different substances are made. Okay, let's move on. Now, iron is a metal and sulfur is a non-metal. Explain why it is easier to separate iron from a mixture of iron and sulfur than from a compound of iron and sulfur. So why is it easier to separate iron from a mixture of iron and sulfur, but not from a compound of iron and sulfur? Last question. Last question. Manal Ahmad. Yes, Manal?
Teacher, can I answer?
Yes, okay. Yes, okay, go ahead.
Teacher, can I
Yes,
answer?
yes,
Furqan Azhar,
please.
can I answer?
Yes, 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 please.
Teacher, it can be separated easily because sulfur is non-metal and it cannot attract to a magnet, and iron is a metal that can attract to a magnet. So metal
Yes,
will
okay, but
attract iron and they will be separated.
right, but why cannot iron be separated from iron sulfide? Can you answer that? Why can't?
Because chemical change has occurred.
Yes, yes, very good. Yes. And also, yes, okay, Sidra wants to answer. Okay, Jazakallah khairan Furqan, that was a wonderful answer. I liked it. Good job. Yes, okay, Sidra.
It cannot be separated because the properties of iron are changed, so you cannot separate them using
Right, right. Another thing that I would like to add is that iron is now bonded to sulfur. Iron is now bonded to sulfur. So that bond does not allow it to behave in the same way as it was behaving before it got bonded, right? So that bond does not allow it to behave the same way. Okay, so we will continue from here. We couldn't do all the questions, but inshallah we will do at the end of the chapter. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh. Jazakallahu khairan for your cooperation.